What's going on, YouTube? Welcome back to another episode of my video, and today I got something good for you. Today I'll be talking to you about the u-substitution. Yes, I said it, the u-substitution. Alright everybody, with me today I got two problems where I'll be talking to you about this u-substitution. Basically what it means is it's under the power rule. Hey, and one more thing. The only way for me to explain all these theories and for you guys to be able to understand everything that I talk about is for me to do problems. That's the only way, that's the only one way you can actually learn all these things, alright? So, let's not beat the bush and let's just get right into it. Alright, so as you can see, I got two problems and here they are. Boom, right there. All right, so here we go, everybody. So, like I said, this is a u-substitution, very simple, very easy, and all right. So here's the first problem. So when you're given a problem like this is integration, right? When you're given a problem like this, you're expected to find the value for this problem using integration. But within integration, there are different ways and methods that you can solve this problem. One of the ways you can solve this problem is through the power rule. And what does the power rule say? The power rule basically says that just where there's x, you're gonna substitute that for u and then solve it and then later replace back the x. Alright, as we'll see how things go. Alright, so here let me start this problem here. So the first thing you gotta be able to do is substitute. And what are you gonna substitute? You're gonna substitute whatever's in the parentheses, okay? And in this case we're gonna say let u equal 3x minus 1. Alright? And then after doing that, you're gonna take the derivative, both sides. So taking the derivative of u is just gonna be du, alright? And then this other side, you're just gonna end up getting 3 dx. Make sure you put that dx, alright? That's very important. Alright, so from there what I do is I make dx the subject of the formula, alright? So I divide both sides by 3, and that ends up being du over 3. Okay? So what I've just done right here is just made dx the subject of the formula. And what this means is that you see there's a dx right here and there's also dx right here. So I'm just going to replace this dx, the new dx that I just got, into the original equation. Alright, so let me do that. So my question once again says 3 into 3x minus 1 to the 4 dx. Alright, so now this whole problem changes again. And now instead of writing it in terms of x, I'm going to go ahead and write it in terms of u, alright? So I'm just going to get 3. Now, this whole term inside the parentheses, 3x minus 1, change, and we let it be u right here. So instead of this term, I'm just going to indicate it as u. So I'm just going to get u right here to the 4. Okay, make sure you put that right there. Times, there's a dx, which you just found it here, okay? So instead of dx right here, you're going to change it and write du over 3. So here I go, du over 3. Boom. And there you go, my people. So after that, so obviously this 3 and this 3 will cancel. So that will leave me with an integral of u to the 4 du. And this is very simple. This is just basic integration right here. So this will wind up being 1 over 5 u to the 5 plus c. Constant of integration. That's very important. Make sure you don't forget that. Alright? Cool. So are we done yet? No. We're just getting started, baby. We're just getting started. Alright, so the next thing is for me to go back to the question, because the question is given to me in terms of x, as you can see. And I'm expected to get the final answer in terms of x. But keep in mind, our answer that we just obtained right here has a factor of u. So I gotta go back right here and see where u is. U will let it be 3x minus 1. So I'm gonna come down here. That is if I have space. So I'm just gonna have 1 over 5. Oh my goodness. 1 over 5. Now instead of u, I'm gonna put, oh sorry. See? And like we said, since we let u be equal to 3x minus 1, so I'll come back here, instead of u right there, I'm gonna put in 3x minus 1. So my final answer was gonna be 3x minus 1 to the 5 plus c. And there you go, everybody. That's my answer. Alright? Alright, so let's jump into number 2. Alright, everybody, here's number 2, and I wouldn't want to say this is a tricky problem. It's just gonna remind us a little bit of cosine and sine, and you know, their derivatives on integral, but it's not a big deal really. So let's jump into it. So the first thing we gotta be able to do right here is I'm gonna let u equals to cosine of x right there, okay? So I'm gonna let this cosine x squared equal to u, alright? So the next thing I'm gonna do is just put back the u there, alright? But before I do that, I gotta make sure I integrate this. So integrating that will leave me with du on the left side, and then the derivative of cosine is the same as negative sine x dx, okay? Always remember that. And then making the x the subject of the formula is gonna give me du minus du over sine of x, okay? So that's my dx right there. Alright, so I have a dx, I can plug it back into the original equation. So this will leave me with, instead of cosine squared, I go ahead and put the u squared right here that I just let. So I'm just going to have u squared times sine of x times my dx, which is just right here. I'm going to pull out that negative outside, and then I should be able to end up having du right here over sine of x. Alright? So obviously here this will cancel, and that will just leave me with a negative u squared du. And this is just basic, again, basic integral. Anybody can do this, alright? So this will wind up being negative u cubed over 3. Alright? Cool, but are we done yet? No. Always remember, you gotta put back the u in terms of x, okay? So our u initially, will let it be cosine of x, okay? So plug it back right in there. So you're just gonna have negative cosine x, but it's a cube now, okay? So you're gonna cube this, and then 3 down here, okay? Plus a constant of integration. Always remember that, okay? If you do not have limits, like the question we have right now does not have limits, always remember to put in the constant of integration at the very end, okay? Thank you for watching my video. Make sure you subscribe. If you don't subscribe, at least like my video. Please. Anyways, hope you have a good day. Stay blessed, stay focused, keep your feet on the ground, and keep reaching for the stars, baby. Peace.